Hey, it's been a minute, but we're going to talk about panels today. Um, Mainly in this video, what we're going to focus on is the panel hardware and panel reveals. So there isn't a whole lot of hardware when it comes to panels compared to like what we just experienced with cabinets. So we're going to talk about that a little bit. Um, I have examples to hold up and show you kind of like some of the things that we're going to be using when it comes to drawing some panels. Um, we'll start with, well, actually, and then we'll get into the reveal side of it from there. So, um, taking a look, I'm just going to make that a little bit off to the side here so I can actually show you what I'm dealing with here. So, panels, when they're on a wall, we typically will use what is called panel cleat. This is not a bought item. This is an item that our shop up in Loves Park actually produces. Um, and it looks like this. So it is two separate pieces. Each one of these is meant to clip onto the other one and lock in place. So kind of just hold the panel up like that. So what you're going to see is that in the side profile of this, which will bring up an actual CAD drawing of it too, but in the side profile of this, you're going to see that there are notches down here and up here as well. So these notches here are actually for screws, like fasteners, so that way the head of the screw doesn't stick out past the cleat, which would make it not level with the wall. So what they're there for is one set of these, oops, my hand's in the way, one set of these will be attached to your panel and the other set of these will be attached to the wall or any of the, or well, the wall. So the one here at the bottom, this one here will be screwed in with screws here into the wall, which would be on this side of the cleat. So the wall is going to be here. Your screws are going to go here into that wall. All right. And then this other one that's here, this will be screwed into the back of your panel. Just like that, just like we did for the wall. So the screws are going this way instead. Now, once your panel is attached and your other cleat is attached to the wall, what's going to happen is your panel is going to come up over the top of that cleat that's on the wall and it's going to drop down. And that's what holds it in place, that little lip that's on there. These are also sometimes referred to as French cleat, but we call them panel cleats, or in this case, wall panel cleats here. When you have panels that are up on a ceiling, which will happen eventually down the road, we will actually use a very similar cleat. It's the exact same profile, it's just made out of a different material. This here is particle board here, which is kind of, if you look at it closely, you can kind of see that it's kind of like chipboard. It's kind of made a little bit out of a rough material. It can be a little less sturdy than our ceiling panel cleats. Our ceiling panel cleats are constructed out of plywood, which is a little bit more durable. Of course, when you're hanging something from the ceiling, you want to make sure it's not going anywhere. So when you do actually have ceiling panel cleats, they're going to be mounted like this. One side will be attached to your ceiling. Oops, this side here. And this side will be attached to the back of your panel. And just like wall panel cleats, they kind of just slip over each other, lock in place. And that's kind of how those work. Now, ceiling panel cleats, again, will be made out of plywood, not particle board. I just don't have an example of a plywood cleat here at my desk. So anyways, that is panel cleats. In addition to panel cleat, occasionally you will see when space is limited or if an architect is pretty adamant about using these, you have what we refer to as hardware 20 in our system, or in this case, this is a Z clip and a Z bar. These are just Z clips, but in real life, you'd have a Z bar, which is a longer version of one of these, and that will actually attach to the wall. And then you have your Z clips, which are these little 2-inch pieces that are manufactured like this. They're made by a company called Monarch Metals. And you'll see that in your tool palettes under hardware. Actually, I think it might be under panel hardware. But anyway, you're going to find that in there. And they work almost identically to the same way our panel cleats work. They're just a little bit smaller scale. And being that they are smaller scale, they are a little bit harder to work with. We also have to buy these too. We can't make these in our shop. So these are a bought item, hence why it has hardware 20 as the hardware number on them in our system. So anyway, they do work exactly the same. Again, they're just smaller scale, and they have a tendency to be a little bit flimsy. Now they're pretty sturdy, but like in comparison to like the panel cleat, we prefer to use panel cleats more than we prefer to use these. It's just easier to work with for the install team, and it's easier to shim panel cleats off the wall if the drywall is not straight, like if it's crooked or bowed at all. So anyway, those are your different hardwares that you're going to see within panels. You have your Z clips and Z bar, hardware 20. You have your panel cleat or your wall panel cleat in this example here. And then if I had a ceiling panel cleat, that would be more like this, and that would be made out of plywood and not particle board. So yeah, that's the 3 different attachment hardwares that you're going to see within the realm of panel drafting. And then after you've kind of gotten familiar with those, we have to talk about reveals. Now, reveals, there are certain ones that are required, and then there's other ones that are sort of, I don't want to say optional, but you do need them between panels and where a panel transitions to drywall. Now, when you are working on drawing a set of panels, it is important to keep in mind that if you're using things like wall panel cleat like this, you will need, drawing a quick little section here real quick here for you. It is important to take note that when you are using wall panel cleats that you will actually need what's called lift-off space. And you're going to need this for Z-clips as well. But I just want to show you why it's important and why we do need to show it on our drawings here. Okay, so let's pretend that this pink line that's here is a wall. Like that's drywall, it's a vertical wall. And then you have your panels butting into a drywall ceiling up here. Well, that would work in a perfect world if you were able to do this, but with using our standard panel cleats, how these work is that, as you can see here, as you go to install this panel, let's say this panel is off to the side here, and this is, you're about to put this on the wall. One sec. Let me hatch that too, because it's going to bother me otherwise. All right. So if you were to take this panel and you were to try to install this thing, one thing that you're going to see right away is that I can't necessarily just slide this thing in just like this. I can't just go right through because those 2 interlocking pieces of the panel cleat are going to hit one another and you're not going to be able to install that panel properly. So that's where lift-off space becomes a thing. So what you really need to do is when you're using wall panel cleats, you do need to make sure that you are giving yourself a 3/4 inch gap at the ceiling whenever your panels are butting into a ceiling. So an architect isn't going to show this on their drawing most times. You'll just have to kind of know that that's something you have to look out for. So it's something worth flagging and kind of writing down. So as you go into drawing panels later, it's something you want to make sure that you catch. So if I go to install these panels now, that I've got that 3/4 inch gap at the top, you'll be able to see what's going to be able to happen here now is now I'm not limited to just running the panel straight back. What I can do is I can take that panel, lift it up, and then slide it back just like this, and then bring it down. So that motion there is how these panels and these panel cleats work. You have to be able to lift that panel up and then slide it back and then drop it down for it to actually interlock with the other cleat that's on the wall. So really, really important to note. And again, that dimension that you're going to need to remember for these is that these do need to have a 3/4 inch gap between the ceiling and the panel. So just like that, 0.75. Okay. Now, some other dimensions that we're going to look at here too when dealing with panel cleats is that you're going to need to remember that between the back of your panel and the start of your drywall, you need to include a gap of at least, we usually make it 1 inch. I know that's kind of rounded a little weird, but this dimension should read 1 inch between the back of your panel and the drywall here. That is also really important, even though the cleats are not an inch thick. The cleats are actually like 0.6875. We include a little bit of what's called shim space down below. So between the cleat and the drywall, we include a little bit of shim space. And again, what that's for is when the installer goes out to the field, if we don't include any shim space, then what's going to happen is that cleat and the panel are going to be subject to whatever the wall is built to. So I guess looking at it from like the top-down view, if a drywaller comes in and they were to build a wall, in reality it should be a straight line just like this, like if I'm looking at it straight down from the top. But in the real world, that may not always be the case. Actually, most times than not, the drywall does move, like it's not completely flat, and it might be a little dramatic the way I'm sketching it in, but sometimes drywall can vary a little bit. So although this line is where it's supposed to be, it may have a little bit of like crookedness to it as the wall is being built. These drywall walls get put up super quick. They usually have a tendency to have some issues with them being kind of like out of whack a little bit. So what we'll do is we'll put shim space on the back of that cleat. So what happens then is the install team will go out to the field. They're going to take a laser out there and they're going to laser the wall, meaning that they are going to find the lowest point and the highest point of that wall. So in our case, it looks like that's probably the highest point, meaning this part sticks out the furthest from the studs. And then they're also going to be looking for anything that looks like a lowest point. So like if I go straight down, I guess that's not my lowest point. It looks like the lowest point is probably right here. So what they do with that information then is they will add more shim to the areas that are lower or more concave, and they're going to add less shim to the places that are higher or sticking out from the wall further. So see, Greg, that's more of an installer aspect as to why we include that shim. For your drawing part of it, the important fact is that we just need to make sure that we show that 1 inch gap between the back of our panel and the drywall. So again, that's what we're looking at right here. And that shim is really just to make sure that those panels stay flat even if the drywall is not. If you don't include the shim space, then those panels are going to be just as wacky as the wall is. So that's why it's important we make sure we got that in there. Now, whenever we do a panel like this, where you have a ceiling above it, and you need to have that little 3/4 inch lift off gap at the top, we can't just leave that gap the way it is. We actually have to put a finish on it. And so what that means is that we're going to make this a full depth reveal. that full depth reveal, what it'll be is we're going to throw most likely like a 3/4 inch block by 1.5 inch block of material. Typically, it's going to be the same finish as the panel, and it's going to sit right there, right behind the panel, just like that. Okay, and so what that does is it still allows you to be able to lift this panel up and push it back so that way you can actually interlock these cleats still, but from the side of the room as you're standing back further in that room, you're not seeing drywall above the panels. You're actually seeing something that matches the panel. So it makes it look very nice and clean, like finished. And then there's also a small gap here that you're kind of seeing there. What we'll do with that is we'll just make that shim space too. So behind that full depth reveal, we need to include that also as shim space to still maintain that 1 inch gap between the wall and the back of our panel, but still work within like what our limitations are. So our core material there is 3/4 thick, but we have a little bit of shim space behind that. Okay, so that is your traditional panel cleat when you're dealing with wall panel cleat. When you're dealing with ceiling panel cleat, well, I won't go there yet because ceiling panel cleat is going to be like pretty much the same thing. It's just you're dealing with the cleat flipped the other way instead of on the wall. So we'll probably talk more about that later, but let's kind of go into the requirements for using like the Z-clips instead. Let me copy the the drawing that we have here just so we can recycle that and reuse it. So this was our first one here. That's the panel cleat. We move over to here. Now, okay, when we have, let me adjust these a little bit. All right, so let's go ahead and find those Z-clips. I think, if I remember right, I think they are within the panels. No, they're not. I'm sorry. They are actually in the hardware section. And again, they're going to be under attachment hardware. And then under attachment hardware, you're going to see them at the very bottom, Monarch Metal Incorporated Z-Clip. That's what we're going to use here. So again, this is not our go-to. We try not to use these unless, we don't really have much options. And what I mean by that is like if you have a room with limited space or you're not allowed to have your panels off the wall a certain amount, then what you can do is you can switch to Z-clips, which will give you a little bit more room in the room, but limit the amount of space that panel is setting off the wall. So when we're dealing with Z-clips on a wall, we like to give ourselves a 1/2 inch gap between the wall and the back of our panel. Okay, and again, you can see the Z-clip is not touching the wall as it currently sits. That's intentional because we still do need to build in a little bit of that shim space. So that shim space is going to sit right here, and that'll be between the Z-clip and the drywall right there. Okay, and shim again is represented just by throwing a diagonal line through a rectangle just like that. That's how you show shim on a print. And again, this dimension here between the wall and the back of the panel is a 1/2 inch thick, or 1/2 inch setback, I guess. All right. And then just like the panel cleats, we still have a lift-off space for Z-clips, but instead of a 3/4 inch one, you can go as far down as a 1/2 inch. So what I want to do is just kind of decrease this a little bit to a 1/2 inch tall instead. And I'll kind of represent that here just by drawing that in. Okay, so you can kind of see that a little better. I'll make these all red here as well so you can kind of see the difference in layers there. Okay. Whoops. What just happened there? All right. Anyways, yep. So Z-clips, you want a 1/2 inch gap between the panel and the wall. and you want a 1/2 inch gap for your lift-off space because they are smaller and they don't require as much lift-off space to install these panels. When dealing with the traditional panel cleat that we use in our shop, we do need a 3/4 inch gap at the top for lift-off space, and we do need a 1 inch gap between the wall and the back of that panel. That's really, really important. Okay, so that's kind of how to utilize those hardwares within panel drawing and how they get installed in the field. What we're going to do next here is we're going to move into what types of reveals you have for your panels. So let's see. We've got a set of regular panel reveals over here. These should also be within your tool palette. If you go to panels and you go to reveals, you'll see all of these here. All right, and we're going to go through these one by one. So most projects that we have at Onsite, anytime you have a panel to panel interaction that you need to put a reveal in, we prefer to use what's called a spline reveal. And a spline reveal looks like this. It is a reveal that uses a thin piece of material. It's about 1/4 inch thick and is 1.5 inches wide. What happens is we will route a groove into the side of the panel that's going to accept that spline. And we'll route a groove into the other panel that is also going to accept that spline. And then once you're done, in between your panels, you should have a 1/4 inch gap or 0.25. That gap lives there, and the intention for it is so you can actually see the spline. The spline's going to get finished to match the panel typically. And sorry, we'll finish the spline to match the panel. We'll also finish the insides of these grooves as well, so that way everything looks nice and intentional. Now these details here are built around the thought process that I am using panel cleats. So if you're using these details, they do show a 1 inch gap between the drywall and the back of your panel. And that is, again, intentional because most times than not, we're going to be using panel cleat for our drawings. Every once in a blue moon, you will need to have a Z-clip type of hanging method for your panels, but most times you're just going to use that. So again, spline reveals, anytime you have a panel-to-panel drawing or panel-to-panel interaction, you're probably going to want to use a spline reveal. It's a good idea to follow up with the project manager or re-review the handoff meeting or just speak with the lead drafter on the job to see if they have information on that. I wouldn't just assume that you're going to use a spline reveal every time, but I'm just saying 90% of the time it's probably going to be a spline reveal between two panels. All right, moving on down the list, we have other types of reveals. This one here is called a cork reveal. Cork reveals are pretty basic. What's going to happen with that is the shop is going to run a route through one of the panels. The other panel will kind of just butt to it. And we don't use these as often, but it does get used occasionally. So the cork is what this groove is. That's what a cork is. So they run a router through that panel, create that cork. Cork gets finished, panel gets finished. Boom, you got your panel there. So that gap there and the gap between splines, also there is a purpose for that. We'll talk about that in just a sec once we get through the rest of these. I just want to make a mental note, making sure we come back to that. All right, next up we have what's called a full depth reveal. So we've already kind of seen one of these earlier when we were working on our panel attachments up above. So full depth reveals, all that is between your panel and the wall, you're going to show a block of material that is the same finish as the panel. And it's going to sit, like I said, between the panel and the wall. So kind of like sandwiched back there. Your panels will just be set back a little bit from the left and the right. These can vary in gaps. Right now, this is shown at a 3/4 inch gap between panel to panel. And we, again, don't really use this as much between panel to panel drawings or interactions, but where you will see this most often is you will probably see this most likely whenever you have a panel that butts into drywall. So if your panel is running into a drywall wall, we usually will use a full depth reveal between the drywall and the stop or the edge of our panel there. So um, then the last thing you have here is a butt joint, and we do not use these pretty much ever. They are really not the best at like being able to line things up in the field. Really, you want to avoid this one at all costs if possible. Butt joints literally are just two panels that are just sandwiched together just like that. No reveal really between. So sometimes you'll see that as a field joint too when you're dealing with countertops. So you've probably seen that before in cabinet drawing too. But in panel drawing, we try to avoid this as much as possible. That is a butt joint there. All right. Now, I wanted to come back to this though too, because reveals do serve a purpose. So most times when you're drawing panels, we try to stay within the limits of what our shop is capable of, and also try to stay within the limits of what the material is. So if you're dealing with a sheet of laminate, like if you have a laminate panel, you want to make sure that that laminate sheet, or what the max size that you can get that laminate sheet in, um, is, because like if you have a laminate sheet that's only available in 48 by 96 or 4 by 8, you can't really draw a panel that's bigger than 4 by 8 because it's just not possible to build one larger than the laminate sheet size. Yeah, so you got to pay attention to like what your material limits are. You also want to pay attention to what our shop limits are. Currently, what we try to do is we try to keep our panels, we try to limit them to be 48 by 96, although sometimes you may see larger panel sizes than that. But we try to stay within those because it's a much more manageable size. It's easier to ship them, it's easier to get them through the shop, and easier to get them through the building once you get those panels delivered to a job site. Any panels that are larger than that start to become a little bit more, I guess, harder to manage. They're harder to get through doors, harder to like move around and ship because they take up more space. So typically we try to make our panel sizes no more than 48 by 96 if possible. But that won't always be the case. And if that's not the case, then what you should do is check in with one of our listers or the shop and just see what our limitations are for our panel construction at that time. All right, so reveals, what they do is they break up material, so that way you don't have a wall that's like 200 inches long and it's realistic to put joints in between, but it's more realistic to put a reveal in between because that helps break up the material. And it also helps make sure that if this panel sticks out a tiny bit further for whatever reason, that you're not going to be able to physically see that this panel sticks out like a hair more than this panel. That's where butt joints kind of don't really do a good job of being able to really work like that, because as soon as this panel sticks out further than this one, you are going to see that like nothing else. So that's why reveals are really important, making sure that we're able to break up material sizes, but also make things look professional and very well like finished all the way around. So those are your panel to panel interactions. Now you'll have like panel corners that are also pretty common too. So like we probably won't talk about this one because you really don't want to do that. But you know, you may have like a butt joint like that. That's a different type of butt joint. That's where two panels are coming together at a corner. You can also do what's called a miter joint. So where you have two panels that come together at a corner, you can cut them at 45-degree angles and then stick them together, which will create a nice little miter like that. You have things like quark reveals on corners like this too. So again, just like the other quark reveal we showed earlier, this one would be the shop would route the side of the panel. And then this panel kind of butts into the side of that panel. But this quark helps separate the material so you don't see any sort of like discrepancy in panels meeting other panels. We occasionally will see this one, maybe once every 2-3 years. An architect gets a little bit creative and they come up with a corner quark reveal sort of thing where they want like the panels to meet, but they want to see like a weird cut through at the corner. So what we come up with as a company is we usually will use what's called a rabbited quark reveal, which is like a hybrid. Whenever you see a rabbet or you hear the word rabbet in millwork, what it is you have a notch that's made to accept another piece of material, meaning that this panel here has a rabbet in it for this panel to die into or butt into. All right, and then when you look at it from the room side, what you're going to see is you're going to have this area that looks like a quirk, but what it is you have two panels that kind of come together with that rabbet that makes that quirk really, well, it kind of actually builds that quirk, even though it's not really a route through the panel. All right. All right. One thing that I will note here, it's really, really important. Again, you might want to write this one down, is that anytime you have panels that are coming together at what's called the inside corner, inside corners, what those are is, let's say you have a room. Just drawing a room here for fun. Let me just redo that real quick. Let's say I had a room that was like maybe, I don't know, 120 by 96 or something. We'll run with that. Well, actually, one sec. Let me redo that again. I'm going to try to do something different so I could show you what the difference between what an inside quirk and an outside quirk would be. So, okay, let's say that I have a room and there's a wall in the room that we're going to put panels on. It's like this weird zigzag shape. Okay, so if we were going to put panels on a wall, typically what we're going to do is we're going to make that panel out of 3/4 inch thick material. We'll put the panel on the wall and then we'll pull it an inch off to allow for that cleat space that we need and the shim space behind the panel. Okay, I'm going to move this over 1.75 inches because that's the thickness of the panel plus an inch of that space behind there. All right, now these panels are going to come together at this corner, and then let's say I have panels along this wall over here as well. Oops. If I have panels on a corner like this, this is what's called an inside corner because it is the it is where the panels are meeting on a, well, it's an inside corner, meaning that the panels are coming together like that. If they're on the outside of a corner, like the one down here, we can miter that all day long. No big deal. That's super easy. So we traditionally will miter corners on the outside like this that are on outside corners. But if you have a corner like this, we will, see it, Cody, we'll typically butt these together because it's going to be very difficult to miter a corner like this. In fact, I've actually talked to the shop about that to see why we actually don't do that. The reason is if we were to miter a corner like this, when you connect two panels together, you're going to typically use some wood glue to do that. And when you have an inside corner, the problem is you'll put some wood glue between these two joints, and that wood glue actually will start to kind of seep out on the inside of that 45 degree. So it would start to flow out of this corner a little bit, unfortunately, which could ruin the finish of the panel. Now that's not a big deal when you have a corner that's like on the outside, because if the glue ends up going behind the panel like this, you're never actually going to see it anyway. So like if the glue starts to seep out the back of these, it's no big deal. But when you have a corner like this, you actually don't want to miter it, because if that glue comes out, that's gonna that's gonna make that panel look not so pretty. So what we're gonna do is we're actually just gonna butt these together instead. Anytime you have an inside corner, that's typically what we're gonna do there. All right. Anyway, that's just kind of a little spiel on that. Just try to keep that in mind whenever you're drawing panels, that if you have something that looks like an inside corner, you really don't want to miter that. You really want to either do a butt joint or some kind of reveal at that corner. When you have an outside corner, mitering is all good all day long. No big deal. All right. I think if there's any other reveals we want to talk about, because that might be it as far as like traditional millwork reveals go. There is a company out there that is called Fry Riglet, and they make metal reveals that go into panels. Um, so if you're dealing with a drawing that calls for some Fry Riglet material, what that is they make these little channels. Like this, here's a U channel. You would usually, what you'd have here is you'd put a panel above this U channel and a panel below this U channel, and this helps break up the helps break up the material. It's a reveal. It's just a bought reveal from this company, Fry Riglet. Um, I'll pull up their website so you can see it, but they make all different profiles and all different kinds of reveals. Let's see, we'll pull that up here real quick so you can see it better. Here you go. So their website's pretty neat. If you ever need a profile that's not in your tool palettes, you can pull it right from their website. They have the shape finder. They have a list of different products that they offer. Let's see, the one that you're going to use the most is this trim and reveal system, and then it's going to ask you what you're using it for. So we'll be using it for millwork profiles pretty much solely. So if you go there, it's going to show you all the different millwork profiles they have to offer. And it kind of shows you like 3D models of what they look like when you assemble them in the real life. And so if you scroll down, you can kind of see actually example pictures of them too. So these are square panels that have Fry Riglet reveals in between. If you keep scrolling, you'll see they have different finishes, other examples of their work that they've done. They make several different variations of these, ones that actually have lights in them, ones that don't. You know, I guess possibilities are really endless with this stuff. The only problem with them is it takes a long time to order and receive material from them. At least today's age, it does. It might not by the time you're watching this video, but yeah, so it can take a while to order materials from them, which is why we usually stick with our traditional reveals. Plus, our traditional reveals are cheaper because we don't have to go out and buy them from another company. We can actually produce those in our shop. So like these are used really only if an architect is specifying they want to use these on a drawing. So if you do see that on your print, I would definitely look at the takeoff, try to see if Fry Riglet's in the pricing for that drawing. If you want, you can also verify with the project manager or the lead drafter too, to make sure that we're actually using Fry Riglet profiles for that print. See, Keith. So that is another type of reveal that exists in the world. And not used as often as the other reveals that we talked about, but they do exist. So I wanted to at least show you that in person on here so you could kind of see what those look like. We have most of their profiles available to you in your tool palette. If you go over to your on-site panels tool palette and you go over to reveals, you're going to see the standard millwork reveals at the top, but you're going to see the Fry Riglet reveals below that too. So most of those are pre-drawn for you. If you can't find the exact one you're looking for, you can go to Fry Riglet's website, and if you click on any of these profiles, you're going to see that it's going to open up a little sub website for that reveal type, and it's also going to allow you to download in the product resources. You can download CAD drawings of that product. It will give you a .dwg file. You can just open that up in AutoCAD, paste it into your print, and boom, you've got a FryRiglet profile there. So that's different reveal types that you're going to see on panel drawings. We've kind of gone over that, kind of gone over the hanging hardware that you're going to use for those panels as well. By the time you watch this, there may be other panel hanging methods, but the ones that you're going to probably see the most are going to be your, again, just to recap, your your wall panel cleats, which would be these guys, your ceiling panel cleats, which are made out of plywood, but they're the same profile, same deal, and then your Z-clips by Monarch Metals Incorporated, and that's hardware 20. So again, just keep in mind, you want to make sure that you remember these numbers here. These are really important too. Make sure that when you're using panel cleats, you have a 1-inch gap between your panel and the wall, and a 3/4 inch lift-off space at the top if there is any obstructions between the top of your panel and the ceiling or anything like that. If you're using Z-clips, you can go down to a 1/2 inch gap between the wall and the back of your panel, and you can use a 1/2 inch gap for your lift-off space at the very top of your panel there, like that, if there's an obstruction in the way. If there's no obstruction in the way, like if there's no ceiling up there, you actually don't even need this gap. You can just show the panel continuing up just like normal. So that's about it though. So as far as panel hardware and reveals go, we'll call it there. And in the next video, my game plan really is going to be, I guess we can really get into drawing a example panel drawing. I'll have to keep my eyes peeled for one that's out there that we can work on together, but I'll find one and we'll go through it together and talk about what it takes to draw a panel drawing.